I'm grateful for the opportunity to present our research work. The theme of my presentation is both oxygen catalytic kinetics of carbon nanotubes by oxygen-induced electrodensity modulation for advanced zinc-air batteries. As well known, with the constantly increased development of various electronic-like football fans, electronic skins, electronic vehicle, artificial intelligence, medical equipment, and green-scale energy storage, it is becoming unprecedentedly urgent to develop competitive power source with high energy density, reliable stability, and statistical flexibility. Zinc-air batteries possess some advantage like long cost, intrinsic safety, accessible working conditions, and high theoretical energy density. The disadvantage is mainly including long power density and high satisfied stability. Present air conditions of ZABS generally suffer from the sludge kinetics of the oxygen reduction reaction, OR, and oxygen evolution reaction, OER, and frustrating reversibility, which badly limited their practical power density and cycling durability. So, the importance is to develop efficient oxygen catalysts to boosting the reaction kinetics of OR and OER. Currently, noble metal-based materials are currently recognized as the best conditions for OR and OER catalysts. Unfortunately, due to their high cost, long abundance, and unsatisfactory stability, the commercial application of precious catalysts is severely held back in rechargeable ZABS. Carbon materials such as carbon fibers, graphite recently emerging as potential candidates of oxygen catalysts in ZABS because of their high conductivity, serious chemical stability, recharge structure diversity, tunable physical and chemical properties. In this work, we grow 3D carbon nanotubes onto the carbon-closed surface through a chemical vapor deposition method, and oxygen gas was further introduced while a one-step electrochemical oxidation method. SEM images show that scientists form a crisscross network on the surface of carbon clouds, and their morphology is basically kept after electrochemical activation. More elaboration microstructure of scientists and OCNTs are further analyzed by TEM. Based on the particle efficiency of the carbon surface, the BAT analysis also verifies that the specific surface area of OCNTs on carbon clouds is remarkably larger than that of the CNTs, meaning that the specific surface area of CNTs can be dramatically increased upon the electrochemical oxidation process. The intensity ratio of D-band and G-band in Raman spectra rise from 1.04 to 1.35 provides the increase of surface disorder caused by oxygen introduction. From the oxygen 1s spectrum, we can see that the electrochemical oxidation of CNTs breaks in the increase of total oxygen content with the formation of oxygen functional groups. Also, the introduced oxygen groups are able to tell the surface wettability of OCNTs. The surface of OCNTs is super hydrophilic compared with CNTs. The OR and OER performance was evaluated. The OR catalytic performance of OCNT is boosted as demonstrated by its significant high onset potential and half-wave potential, in contrast to those of CNTs. Likewise, it also possesses better catalytic activities towards OER than the CNTs, exhibiting a long overpotential of 316 million watt and 10 milliampere per square centimeter and smaller tougher slope. The active surface area of OCNTs is also remarkably superior to CNTs. Manifested amount of activity sets are created after introduce oxygen functional groups. In addition, the reaction kinetics of OCNTs is significantly enhanced. Their results reveal that the electrocatalytic performance of carbon material can be optimized by the oxygen function modification. Density function serial calculations was also performed to unveil how electron density modulation affects the catalytic performance of CNT at the atomic level. Different charge density distribution clearly revealed that the strong interaction between the oxygen functional groups and intrinsic carbon atoms, international remarkable electron accumulation on oxygen atoms, and obvious electron depletion on carbon atoms. This result is also proved by bad charge analysis. In addition, all OCNT samples showed high calculated work functions than present CNTs. In addition, indicating oxygen regulation range could effectively modulate the electron density of CNTs, and is also be confirmed by experimental results. The reaction-free energies of the reaction pathway are calculated, demonstrating that oxygen functions groups can boost catalytic activities of CNTs for both OR and OER. To exemplify the feasibility of CNTs and OCNTs for practical application, we assembled liquid zinc air batteries diverse by using CNTs or OCNTs and the air cathode. The zinc OCNTs batteries showed a high open circle voltage of 1.45 watt and a suitable power density 113.5 milliwatt per square centimeter. outperforming both the zinc CNT's battery and most of recently developed ZABS. The discharge caps showed the zinc OCNT batteries possess a higher discharge potential plateau and long charge potential plateau than zinc CNT's batteries, indicative of the better root trip efficiency of zinc OCNT's battery. Impressively, the zinc OCNT's battery also displays long-term cyclic durability. See negligible voltage gap change after 314 hour change and discharge test. We also designed a high flexible all-solid state ZABS by assembling zinc and OCNTs in PAA hydrogen electrolytes. Both the output voltage 1.39 watt and the power density 103 million watt per square centimeter of the diversity are slightly lower than those of the liquid ones, but still higher than those most of recently reported all-solid state ZABS. Verify its superior flexibility, mechanical strength, and structure stability, and the demonstration for practical application. 204 diverse in series can power LED lights and a toy, respectively. Summarize a facial oxygen-induced in electrodensity modulation string to effectively manipulate the absorption-disorption capability of reaction intermediate on carbon sets. Such surface electrodensity modulation compared to a relative high positive charge density on carbon atoms, while which become more energetically favorable for both oxygen catalytic kinetics. The oxygen modulated CNTs enable high performance liquid and flexible solid states ZABS with a high power density and a long-standing cycling durability, which outstrip most of recently reported diversity. Well, this is all my presentation. Thank you for your attention. Bye.